Hey kids, welcome to another lesson for Module 4, and this is Lesson 15, where the objective is to multiply non-unit fractions by non-unit fractions, just a fancy way of saying, hey, we're learning how to multiply fractions. Now, I would say the most important part of this lesson is that we are really transitioning from area models to using the standard algorithm with cross-canceling. So, I was telling my students that when all else fails, please remember that multiplying with fractions, you can just multiply across the top and multiply across the bottom and worry about simplifying later. So a lot of kids will do that. If you have like a 2/3 of 3/4, you can use the dot instead of an X for multiplication. And if you don't know how to cross cancel yet, you can simply do 2 times 3 for 6 and 3 times 4 for 12. Now, when you get to this point, this is the lesson where they're saying, hey, you really need to learn how to simplify your answer. And so this is where you go back to if you have nothing else, Mrs. Setness's rules for simplifying. So if you see what I call the doubles, where it's doubled on the bottom from the top to the bottom, those are always equal to half. Why does it work? Because you're using the top number as your divisor, and whatever you do to the bottom or the top, you do to the other one. So you have to reduce or scale your fraction up or down at the same rate. So if it's 6 that is going to simplify, it's 6 divided by 6 and 12 divided by 6 to give you the 1/2. Now I have a lot of notes and it kind of gets busy, so bear with me while we kind of buzz through it real fast. If you take your 2/3 times 3/4 and you see that you can cross cancel with the 2 and the 4 if you were to switch places using the commutative property, 2/4 is equal to 1/2 and 3/3 is equal to 1, you can multiply and get 1/2 with doing all the cross canceling. Okay. Now if you go down here a little bit, I have a couple of models. So let's say our problem is 1/3 of 3/4. Okay. So how do I know I'm going to get 1/4? All right, well, if this is the 3/4 and I'm taking 1 out of 3 parts, then that would be where the pink is. Okay, it's probably, you can't really see pink on the video, but anyway, this is pink. 1, 2, 3 boxes. So if I have 2/3 of 3/4, then that's going to give me the pink and the orange because I have 2 of those pieces of the 3/4. So out of the whole, I end up with literally half of the whole. So when I do simplify it, it should make mathematical sense that I would get a half. Now, if this is confusing to look at, just look at the numbers. 2/3 of 3/4. If I can see that the 3 and the 3 are compatible and you just switch the order using the commutative property, 3 divided by 3 is 1. So it's going to be a 1 here and a 1 here, and then it's 2 times 1 for 2 and 1 times 4 for 4. Or you can also possibly recognize that both sides have numbers that can be simplified, and so you can simplify everything before you start and end up with 1/2 right away instead of 2/4 or instead of 6/12. Now here's another one. So if I have 2/3 times 2/3, now if I was to use the commutative property and switch things around, nothing would happen because it's the same. So go ahead and multiply straight across for 4 and straight across for 9. Here's your model, 4 pieces in that double shade out of the 9. More practice problems at the bottom. Here, again, if you can see that they are compatible, you can slash them out. The 7 could be switched with the 9. 7/7 is equal to 1. 3/9 is equal to 1/3. What if you don't see that? Well, you can multiply and get 21/63, which is what you would get if you multiplied 7 times 3 and 9 times 7. Now, if you don't know that this can be reduced, okay, it's going to hurt you because if you can't reduce things, you'll probably not get full credit if they're telling you to reduce and simplify. But what can you do? Well, you can look for something that is a compatible number for both. Like you might say, well, I recognize that 6 and 3 are both divisible by 3, and I know that 21 is a multiple of 3. So I could start by simplifying with 3, by dividing this by 3/3. Then when you get to the 7/21, you go, oh my gosh, I can now simplify by dividing by 7 because both these numbers are divisible by 7. Then you get your 1/3. Now, if, for example, you see that there is something higher, you could simplify by dividing this by 21 in the very beginning, but most 5th graders will not see this. And a lot of teachers won't see it either, so that's not a problem. This is actually a really good method for kind of skipping through with the simplifying. A couple more sample problems. It's all doing the same thing. Learning how to simplify before you multiply. So let's just jump in and see if we can get started with our work, and you'll kind of learn by doing. So lesson 15, problem set, page 213 is where I am. And we're going to solve, and we're going to draw the rectangular fraction model, and we're going to write a multiplication sentence. First one's done for you. If you need help, you can look back. But let's go ahead and jump right in. 3/5 of 4/5. Remember that your fraction model is going to be this one. And so you're going to look at the denominator to tell you how many pieces. So I need fifths. I will shade 4 of them going in all one direction. Okay, and so that's your 4/5. And now I'm going to take 3/5 of that. So I also need fifths going sideways or horizontally. And my crossing pattern is going to be going the other direction. Remember, we're trying to create this double shaded area, but since it's easier to just use a waffle weave or other shading, we're going to do that. And then just make sure you get down here so you can see. Now, these are only going one way, so those won't count for our answer. And these are only going the other way, so those won't count for the answer. But if you take and identify where it is double crisscrossed, all these pieces are the ones that would be the non-simplified answer. So 3 times 4 is 12, and 5 times 5 is 25. So when I see that I have all these pieces, and I've got something that probably looks familiar, you have to start thinking about, well, can I simplify, and is there a divisible number? And you have to think about number bonds and what would be compatible. Now, if your book has 3/5 of 4/5, then you'll probably have this. If your book has something different, like 3/4 of 4/5, then you'll have a slightly different answer. So for right now, we have 12 25ths, and 25 is a multiple of 5, but it does not evenly go into 12. And then, so there may not be a way that you can simplify right off the bat. If you have the 3/4 times 4/5, you will be able to simplify with your 4/4. Some books have different versions, so hard to know what you have, but this one is fine for now. If that's what you have, you leave it for now, is what I'm trying to say. Okay, now if you have 2/5 of 2/3, then we're going to take our 2/3 vertically, shade all one way. Okay, and then the next, or sideways or horizontal, 5 sections, and also opposite direction. Okay, again, where is the double crisscross? That will show you your full answer. Multiplying straight across, you would end up with 4/15. Looking for ways to cross cancel, you see that there's nothing compatible, so we would leave this here as it is. You're always thinking when you get your answer, can I simplify? And we're going to learn in the next on the bottom here, always look to cross cancel before you multiply. All right, next one, 4/5 times 2/3. Making your model of 2/3, because the second one, again, that's what we're doing. 2 of them are shaded. And then we have fifths again. Give us something new and interesting. And so 4 of them, and it doesn't matter if you shade the bottom 4 or the top 4, as long as 4 of them in total are double shaded. Sorry, kind of messy there. But let's do our 4/5 of 2/3 and do the crisscrossing, identify that. And 4 times 2 is 8, and 5 times 3 is 15. And so again, you can count 2, 4, 6, 8 pieces are shaded out of a total of 15. 12 are double shaded out of a total of 25. 4 are shaded out of a total of 15. You should be able to count everything one by one if needed, but that's not as reliable as doing counting by 5s, counting by 2s, whatever you're good at counting by. Okay, next one. 2/3 is our model. And so shade 2 out of 3, because that's what that is. And we have now 3/4. So finally something other than fifths. And we're shading 3 of them. And again, if you would like to put a color on it where the double shading is, then it does help the one-way shading to stand out. If you wanted to multiply straight across here, you would do 3 times 2 is 6 and 4 times 3 is 12. And what you might notice, and hopefully you would right away, is that this is one of those doubles. It's rule 1, or they're always equal to 1/2. How is this so? Because 3/4 times 2/3 can be rewritten so that you could switch. You've got 3 times 2, keep it the same on the top, and switch the 3 and the 4 on the bottom. Now I have 3/3, which is equal to 1, and 2/4, which is equal to 1/2, which gives me a total of 1/2 for my answer, which is what I got when I simplified. Now, how do I simplify this? Well, you can divide by 6/6. 6 divided by 6 is 1, and 12 divided by 6 is 2. So either way, I hope you can see that that's what's happening when you can simplify when multiplying. Okay, now this one kind of leads us into here. And here, hooray, we're going to multiply, and you draw a rectangular fraction model if it helps you, okay? Or use the method in the example. So, yay, we're using the method with cross-canceling, because making fraction models is, we're ready to move on, aren't you? So, 6/7 times 5/8. If you look at the 6 and the 8, you say, well, they're both even numbers. So I could divide both numbers by 2. So I could divide 6 by 2 and 8 by 2. And that's what they're doing here. They're showing you that 6 divided by 2 is 3, and 8 divided by 2 is 4. You don't have to write the divided by. You have to think about the divided by, and then you write the answer. Then you take your 3 times 5, and you get your 15. 7 times 4, that's where the 28. Okay? So I hope that little part helped you. In fact, if these videos are helpful, click subscribe and come back again. All right, well, let's see if we can simplify this. Is there anything that is compatible? Yes, there is. 3 and 6 are compatible. Divide 3 by 3, because why are they compatible? Because you can count by 3 for both of them. 3 divided by 3 is 1, 6 divided by 3 is 2. Now I'm multiplying 1 times 5 and 4 times 2, and I'm done. And so this is why it's like a lot more fun when we get to this point, because it's so fast. How about this one? I have 4 and 8 that are compatible. And again, if I switched the order, it'd be 5/5 over 4/8. 5/5 is equal to 1. 4/8 is equal to 1/2. There's the 1/2, there's the 1. Multiply across, and done in one step. Isn't that great? Like, I just think these are so fun and easy once we get going. All right. Last 2, and again, watch for cross-canceling opportunities at the beginning. So instead of doing 2 times 6 for 12 and 3 times 7 for 21, I noticed that 3 and 6 are compatible. 3 can go into both numbers. So divide 3 by 3 to get 1, divide 6 by 3 to get 2. And 2 and 7 cannot be cross-canceled because one's even, one's odd. This is not a multiple of that. So I'm going to go ahead and multiply now. 2 times 2 and 1 times 7. And I'm done. Yay. See, easy peasy. Now on this one, we have a double whammy. So I've got 3 and 9, which are compatible, and 4 and 10, which are both even. So you want to simplify before you multiply. Okay, 3 and 9 are both divisible by 3. So divide 3 by 3 to get 1 and 9 by 3 to get 3. Or if you think about it in terms of switching these factors around, it would be 4 over 10 times 3 over 9. That's really what I've done in my head so that I can see this is going to be 1/3. Now on my next step, 4 and 10 are both even. So I'm going to divide by 2. 4 divided by 2 is 2, and 10 divided by 2 is 5. 4/10 is equal to 2/5. Now we multiply straight across. 2 times 1 for 2 and 5 times 3 for 15, just like here, 2/15. And that can't be simplified because 2 is even, 15 is odd, and you will never, there's no other divisor other than 2 or 1, and so we can't simplify. It's done. Okay, so I hope those are easy for you now. And then let's work on these word problems, because these can be a little bit tricky. Philip's family traveled 3/10 of the distance to his grandmother's house on Saturday. They traveled 4/7 of the remaining distance on Sunday. What fraction of the total distance to his grandmother's house was traveled on Sunday? So we're really wondering about the 4/7 of the remaining. What fraction of that distance? So let's make a tape diagram because that will always help you. When you look at the first day, okay, don't forget the remaining is going to be a different piece. So we want to just put together our first day in 10 pieces. So split it in half and then do 5 on each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then let's mark out the 3/10 to the distance on Saturday. 3/10, you can shade it or really whatever as long as you put Saturday. That's not what we're searching for. Oh, the lights. There we go. I need to move around more. Okay. That's not what we're searching for. We're searching for what's left and for our Sunday travel. Now, they traveled 4/7 of the remaining distance on Sunday. So how many pieces are left? 1, 2, 3, 4, 5, 6, 7. Good thing, because that's your denominator. So if they traveled 4 out of the next 1, 2, 3, 4 out of 7 on Sunday, what fraction was traveled on Sunday? So if this is Sunday, label it. And if you want, you can shade it. It's not needed, but you can do that. And so then you're going to take the 4/7 that they traveled of the remaining distance. And so what is the remaining distance? 7/10. Okay, 1, 2, 3, 4, 5, 6, 7. 7 out of 10, and they traveled 4. So 4/7 of 7/10. That's where you get that. You can look at the fraction and see on that tape diagram that it's 4 pieces, okay? But now I have mathematically confirmed that this is how I'm going to set it up, and I can do my cross-canceling. So hooray, because 7 and 7 are compatible. Divide both by 7. And 4 and 10 are compatible with 2. Divide them both by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Multiply across and get 2/5. Okay? Now, 1, 2, 3, 4. Isn't that 4/10? Yes. They're kind of showing you in the tape diagram that that's 4/10. But you can simplify this answer. It's basically what we're doing here. And so 2/5 of the distance was traveled on Sunday. There you go. So I hope that's helpful. I know these are really hard. That's why I make these videos, honestly, because some of these problems are so super hard. Okay. Santino bought a 3/4 pound bag of chocolate chips. Yum. He used 2/3 of the bag while baking. How many pounds of chocolate chips did he use while baking? So basically, he used 2/3 of this bag. 2/3 of a 3/4 pound bag. And boy, when you look at that, doesn't it scream, easy, it's easy, you can do it. Okay, if you wanted to switch these and rewrite it, you could, but why? When you can just cross cancel, dividing these 3's by 3, dividing 2 and 4 by 2, and you end up with 1/2. And so how many pounds? 1/2 pound was used while baking. There you go. That one's fun and easy. There you go. Okay, Farmer Dave. Hello, Farmer Dave. Harvested his corn. He stored 5/9 of his corn in one large silo and 3/4 of the remaining corn in a small silo. And a silo, in case you don't know, is a place where you store grain. It's out on a farm, and they can put it all in there and hold it, and it'll keep it from getting wet, and it keeps it away from the animals, and so it's a great place to store it till you put it in a truck and sell it or take it to market. All right, so we have 5/9 of his corn in one large silo and 3/4 of the remaining. Let's make 9ths. Let's do 3 sections and then make 3 in each section. Okay? And 5 of those 9 are the large silo. 1, 2, 3, 4, 5. Large silo. Okay, you don't have to shade it just yet. Then 3/4 of the remaining. Oh goodness, 1, 2, 3, 4. 3/4 of the remaining 4/4 are in the small silo. I would shade this because they're telling you that out of the remaining, which is what we want to identify, remaining is here, these 4 out of 9. And so 3 of them are in the small silo. And the rest, right there, was taken to the market to be sold. So what fraction of the corn was stored in the small silo? Well, I can see that it's 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So if I have 3/4 of 4/9, which is what I had remaining, then I can do my cross canceling with 1 and 1 for the 4's, divide both by 4. And then 3 and 9, if you switch that, it'd be 1/3. And then you multiply across and get 1/3. If you don't, and you just look at it, you can see that 3/9, okay, is what was in the small silo. And that mathematically can be simplified to be 1/3. And it's, how do I label? 1/3 of the corn in small silo. Okay, so 1/3 of the corn, bam. And we only have one little section left. Now, if he harvested 18 tons of corn, and so that would be the whole thing, the 18 tons, all of it, the whole kit and caboodle. 18 tons of corn. How many tons did he take to market? Well, look at the fractional value. 1/9 is going to the market. So it's 1/9 of 18 tons. And remember from a couple lessons ago, if you have a whole number, it's going to be over 1 because 18 divided by 1 is 18. When you multiply this, you're looking to cross cancel. 9 and 18 are both divisible by 9. If you see that that's the biggest number, you can divide both by 9 and get 1 times 2 for 2. 1 times 1 is 1. Therefore, 2 tons went to market. Yay! And you got this. Nice job. I hope it was helpful, and we will see you on the next video. Goodbye for now.